At any given moment, what invisible system is preventing modern civilization from stalling, and how dependent are we on machines most people barely notice? More than 70% of everything Americans consume moves by truck, not one type of truck. 14 of them, each engineered to solve a problem the others cannot. This hidden system on wheels keeps fuel flowing, food cold, and steel on schedule. Pull just one link out and the cascade begins faster than anyone expects. A light-duty pickup parked at the edge of a driveway looks unremarkable, yet its role in the freight system is anything but ordinary. With a gross vehicle weight rating under 6,500 pounds, this smallest class of truck slips through the city's tightest spaces, carrying everything from tools to urgent parcels. No commercial license is required. The driver needs only a standard license, nothing more than what is needed for a family sedan. That exemption is not a loophole. It is a deliberate design written into regulations to keep the last mile moving. Delivery vans, built on a similar principle, expand the cargo envelope to 300 or even 400 cubic feet. Their compact frames and tight turning radius let them navigate curbside drop-offs and alleyways where larger trucks would block traffic or break the law. These vehicles form the capillaries of the urban supply chain, each run dictated by parking limits, bridge clearances, and the constant threat of a ticket. Every detail, from the weight on the rear axle to the length of the cargo bay, reflects a compromise between capacity and access. These are not scaled-down semis. They are engineered to solve a specific problem: how to move goods quickly, quietly, and legally through neighborhoods where even a minute of delay can ripple through the entire system. The line between convenience and chaos is thinner than it seems. In the world of freight, even the smallest trucks are the result of invisible negotiations between law, physics, and the relentless demand for speed. Medium box trucks quietly anchor regional freight, bridging the gap between neighborhood deliveries and highway trailers. With gross vehicle weight ratings up to 26,000 pounds, these trucks are engineered for a sharp step up in both size and strength. The increase in cargo volume brings new challenges. Every pallet loaded adds not just weight, but twisting forces that threaten to stress the box and frame. To counter this, manufacturers reinforce steel ribs, weld floor pans, and use dual rear axles to keep the structure rigid under load. 12 standard pallets fit inside, a leap from the 4 a delivery van might carry, making each trip count. The 26,000-pound gross vehicle weight rating ceiling is no accident. It marks the legal limit before a Class A commercial driver's license is required, shaping how fleets operate and who can drive. As one fleet manager puts it, the sweet spot is moving nearly 10 tons of goods without extra regulatory hurdles. Pallet math drives the business. More pallets per run means fewer trucks, but only if the frame can handle the stress of city streets and sharp turns. Medium box trucks form the backbone of regional logistics, balancing muscle and maneuverability. A dry van trailer, loaded to its 45,000-pound capacity, leaves the warehouse before sunrise. Its thin aluminum walls hide the standard unit of commerce, engineered for speed, compliance, and efficiency. Every detail, from the kingpin tension to the reinforced doors, is shaped by the need to move freight fast while staying under the 80,000-pound legal limit. Fleet managers call these boxes the backbone of the highway, their dimensions matching pallets, city turns, and overpass heights by design. At the port, a 77-inch wide chassis waits for a 20-foot ISO container. Twist lock pins snap tight, linking global cargo to the interstate in seconds. This system is built for speed, but every move is bound by international codes and federal bridge laws. One miscalculation, too much weight, an uneven load, or the wrong cargo can mean fines, delays, or missed delivery windows. Refrigerated trailers, called reefers, bring another challenge. Their insulated walls and diesel compressors keep loads between -20 and 5 degrees Celsius, with temperature loggers tracking every shift. A broken seal or a 10-degree swing can wipe out an entire shipment. Regulations demand not just cold, but consistency. Every pallet must be placed to avoid hot spots and overloading. Tanker trucks, designed for liquid bulk, rely on internal baffles to break up the surge of thousands of gallons, keeping the rig stable through sharp turns. Placards on the tank announce the cargo, corrosive, flammable, or toxic, and each symbol is required by 49 CFR. Hazmat officers call these rules non-negotiable. A missing placard or a failed inspection can shut down a terminal or trigger a federal investigation. Each truck is shaped by physics, law, and the push for speed, until a single failure exposes the system's hidden complexity. A flatbed trailer, 48 feet long, sits exposed beside a steel yard, ready for cargo that ignores standard shapes, coils, blades, and tanks. Chains and ratchet straps anchored every 4 feet hold the load in place. Operators hustle, checking tie-down tension and axle weights, knowing a single mistake can close a highway or bring a 6-figure penalty. Lowboy trailers, with decks just from 24 to 30 inches off the ground, slip under excavators and bulldozers. Hydraulic goosenecks detach, letting machines roll aboard. Each trip means paperwork, over height permits, route approvals, and sometimes police escorts for loads that skim legal limits. Car carriers stretch up to 75 feet, stacking 12 vehicles on sliding decks. Hydraulic lifts choreograph the load, balancing weight to stay under the 20,000 pounds per axle rule. A missed chock or a broken strap can send a car tumbling, shutting down a corridor. Logging trucks, built for rough forest roads, haul timber on reinforced decks. Special permits allow up to 15 feet of height for a single run. Drivers race the weather, dodging mud and rollovers. Dump trucks rely on hydraulic cylinders rated from 20 to 30 kilonewtons, lifting tons of gravel or debris in seconds. A cracked weld or a blown hydraulic line can halt a site. Pneumatic bulk trailers use from 6 to 8 bar of pressure to unload powders and grains, turning sealed hoppers into flowing cargo. Concrete mixers race the clock, spinning from 8 to 12 cubic yards before the mix hardens. Every truck is a solution to a constraint, height, flow, weight, or time, where the wrong move ripples far beyond the job site. A tanker driver scans the dashboard, listening to the radio crackle with news of a sudden bridge closure. The planned route to the fuel terminal is gone. Detour instructions come in, an extra 90 miles and 2 hours tacked onto the clock. Every minute counts. Local gas stations are already calling the terminal, reporting low tanks. On board, the liquid load sloshes against baffles as the truck winds along unfamiliar roads. The driver checks the clock against the delivery window, knowing that each detour mile drains not just fuel, but also the time left before storage tanks run dry. At the terminal, inventory drops by the minute. 250 gallons gone every 60 seconds with no resupply in sight. Within hours, a localized fuel shortage begins to unfold. The system, so efficient when invisible, reveals its fragility in the space of a single detour. Inside the cab, a refrigerated trailer driver glances at the digital readout, temperature holding, but the clock is moving faster than the truck. The route detour, forced by the bridge closure, adds hours the refrigeration unit wasn't meant to spare. With every extra mile, the diesel genset burns through its reserve. The fuel gauge for the cooling system drops, narrowing the margin for error. A soft alarm chimes, warning that the safe window for perishable cargo is shrinking. The driver checks the load manifest, which lists fresh produce, dairy, and pharmaceuticals, all with strict delivery deadlines. The detour's added drive time pushes the shipment toward its spoilage threshold. Each minute lost on the road brings the entire cold chain closer to a point of no return. The driver's hand hovers over the control panel, calculating whether there is enough fuel left to keep the temperature steady until the next service stop. The pressure is silent but relentless. If the cooling fails, thousands of pounds of cargo are lost, and the chain reaction begins. At a construction site on the city's edge, a crane operator leans against his idle machine, eyes fixed on the empty road. The flatbed carrying structural steel is hours overdue, trapped behind a detour that no one planned for. The site foreman's phone rings again. Another update from the driver, still crawling along a two-lane bypass. Every minute, the beams are missing, and labor costs pile up. A crew of riggers and welders stands by, earning union rates while nothing moves. The cost of delay climbs to hundreds of dollars per hour, with heavy equipment burning fuel just to stay warm. The project timeline slips, and the foreman's frustration grows. There is no quick fix. Without those beams, the entire site is frozen. One bridge closure, one detoured flatbed, and a multi-million-dollar build grinds to a halt, proof that the system's efficiency is also its greatest weakness. This system's strength is also its weakness. The more seamless it becomes, the less we see what's at stake. As automation and new policies reshape freight, our dependence grows, yet our awareness shrinks. The next disruption won't just test machines, it will test the resilience of our entire society.